The research team was able to videotape the same group of students year after year, solving a variety of math problems in combinatorics, probability, and algebra.
Now you're wasting your time doing that, because you're going to put all in one column.
Yeah, and it's not
then you're going to put them the
organized.
same amount in the next column. Then you're going to put the same amount in the next time. Then you're going to cross that out and, of course, now 2 columns worth.
We got so in depth on topics that leaves an impression, you know. I mean, we could talk about, you know, doing the blocks in first grade. You know, we can almost go through the problems. We did shirts and pants in second grade. I mean, how many other people can tell you the math that they were doing in second grade?
You have to write your reason for why you picked that, okay? Why you picked 7 yellow and 3 black.
I have no idea.
She left you space. Jeff. Yes, you do.
No, I don't.
You told me why.
Oh, yeah.
It was basically like what we thought. Like, you know, they were giving us a probability questions, and those I like those kind of questions. Those really get you to think.
Well, since there's 16 to make with those toppings, you put a Sicilian crust on it, and that's 16 plus. Then you
These
put
students
a regular
were always up to the task.
32.
We'd give them a problem, they would work hard on it, and would often take it to higher levels themselves.
And then you
They're
say
gonna go 2,
and 3.
1, 2, well, 2, 3, and
I thought we were real weird. What fourth grader is interested in math and arguing with their own friends about it?
That's how she told me. I still don't agree with her.
Yeah, it is.
Each has to be.
It's half and half. Look, okay, you have a whole pizza, and you split it in half. The pepper, you got 4, and then when you had the sausage, you got 3, and when you had the mushrooms, you got 2, and when you had the pepperoni, you had 1.
Here's this group of students, just, you know, kids going to school, doing what was expected, and now we're challenging them with problems, and they were taking them, solving them in ways that were very impressive to us.
If I stagger it by 1, the surface area changes.
Yeah, because it opens up more dimensions.
We pulled back and gave them more, and they responded to more. And we pulled back and gave them more, and they responded to more.
Okay, and you've come up with a general rule to find the surface area of all the rods if I stagger it by 1.
Yes.
Okay, I can't wait to hear this formula.
Yeah.
Because volume.
I hope that we can show that under certain conditions, and these conditions were not in place all of the time.
There's 3
Remember, we went in 6 times a year in the first few grades, and then maybe 4 times a year in middle grades, and so on and so forth. That kind of an intervention seemed to be very, very important for this group of students. And it wasn't, we did not change all of the curriculum. We did not change, we didn't throw out textbooks. We didn't say to teachers, don't do what you do. What we tried to do is bring into the curriculum thoughtfulness and the notion it's so very important to understand fundamental ideas. The building blocks really have to begin very early.
The students attended 9th grade at the regional school. The subject was geometry. The approach, strictly textbook-based.
I'd sit in the class. My name starts with an A, so I'm in the front. Teacher would just tell us, these are the laws of geometry, or I don't remember half the stuff she said.
In the first year of high school, I had geometry, and the way we learned was sick, I guess you can call it, because it was not taught, it was read from a book. And we never got involved. It was read this and see if you could do it on yourself, and then I'll tell you the answers the next day, which I don't think anybody learned too much from it.
She had, my math teacher had a plan to get through the entire book in 1 year. That was her goal. That's what we were going to accomplish. She had every day, she gave us a sheet the first day of school saying, all right, on day 154, the homework from this chapter is due. And, you know, you could do all your homework in one night if you had the time to do it.
Particularly in high schools, deviations from the curricula are not encouraged for teachers. So I think we have to be careful. But I wonder what we can learn by listening to what those students are telling us. I wonder what we can learn about their own assessment of their own learning over that year.
Ask me one question about geometry. Because I won't know it.
There are many different skills involved in being successful in mathematics. Experienced teachers, like Ramina's AP Calculus teacher, Ralph Pantozzi, know that not all math skills are measured equally on standardized assessments.
Doing well involves being able to actually do mathematical inquiry, to approach a problem and then say, all right, well, I'm approaching it this way, and I'm going to try different ways of going about a problem, and I'm going to look for patterns, or I'm going to look for whether the change in this number creates some change in some other number. Looking for things that might be related to the general question that they're asking. When you see kids looking for that and generating those questions themselves before you ask them those questions, that's really the key, and that's what I've seen this class do.
Because like you go straight line down, so there's no curves, it's just a straight block.
Fascinating.
No?
Yeah, I've never seen anyone say that before. Yeah, that's right.
Yeah.
Do you understand what you just did?
Yeah.
Yeah.
I got that one. Yeah, we were all running that. We didn't need that
I
one.
was on top of everything.
Fine, though.
That's the only kind of question.
I mean, yeah, it's the same thing, though.
Yeah, so I was thinking you'd say that the area of this shape up here was b minus a times 5, but you saw it in a completely different way. Okay, just as valid.
Is this just
I'm very
We know how to do this.
They end up suggesting the questions that I have in my lesson plan, and that tells me that they're doing well because they're actually doing mathematical thinking, and that's the best evidence you can get.
I'm pretty sure my career is going to revolve around mathematics, but I think it's going to revolve around other things too, but mainly mathematics. And maybe not like the math everyone thinks, but like the math that I've learned in the last 10 years.
Accumulated up to 3.
I don't even know what I can go into without math. So any path I choose is probably going to have to deal with math.